Okay, it is time for the chain rule part 2. So what you're looking at right here is the problem that I want to do in this video. It's a fairly lengthy problem, and so it's really the only problem that I want to do in this particular video. But I'm not going to start by just working this problem because I don't think that that's what most people need to see. I think most people need a little breakdown of the chain rule and then some algebra, okay? That we just got to get out of the way. We got to make sure everybody agrees with this. If we don't do that, if we don't make sure everybody's okay with this and this, then that makes this problem very, very hard to do, okay? Now, if you feel like you don't need the review and you're okay with it, but you would like to see the solution of this, well, you could just skip ahead. But I just wanted to tell you up front that I want to do this one. That's the objective, but that's not where I'm going to start, okay? All right, so first of all, like in the last video, part 1, we learned what the chain rule is and that the derivative of u to the n power, where u is some formula that involves the x, some function of x, would be n times u to the n minus 1 power times the derivative of u with respect to x. You could look at that like it's the derivative of the outer function, which is the power, times the derivative of the inner function, which is 2x minus 1. You could think of it like that. And then what we're going to get if we do that is, well, the 2's are going to cancel, and that's a square root under the bar, so we'll get 1 over root 2x minus 1. Okay, so the derivative of this is that. So first, I establish that. Second, there's some algebra, and that algebra can be a real weak point that people discover in calculus. Like maybe you thought you were good at algebra. Sometimes, you know, when you get to calculus, you realize maybe you weren't as good as you thought, or at least maybe there's some things you need to review. You know, there's a lot to know. There really is a lot to know. And you can feel like you're starting to learn it all, but then there's going to be something that comes up that you forgot about or you never learned. And so I wanted to do a little bit of algebra just to get out of the way, just to make sure we're okay with it. All right. How do you add these two things together? Well, you would need a common denominator. They are fractions. So let's do like this. Let's put this like over 1. And my common denominator between these would be root 2x minus 1. So the way that we get a common denominator is we multiply both the top and bottom of that fraction by whatever we need to in order to get the common denominator. So in this case, between those, the common denominator is root 2x minus 1. Given that the denominator of this is already 1, then I multiply by root 2x minus 1 on the top and bottom. Why the top and bottom? Well, because what is this number? What are we really multiplying by? Well, if those two things are the same, then what we're really multiplying by is 1. And so if you take this number and you multiply it by 1, it's the same number. I mean, we don't want to change the numbers because then we're doing a different problem. I need to work with these numbers. All right. So let's see. So we get like this, and we don't need to change this other one. Okay. And so on. Now, how do you multiply these together? Like, what's root 2x minus 1 times itself? Let's consider that 2x minus 1 is not a negative number inside that root, because that would mess things up for us. Like, what is the square root of something times itself? Like, what's root 4 times root 4? I guarantee you it's 4. Okay, the roots do cancel. How can you justify that to yourself? Well, what's root 4? It's 2. And what's root 4? It's 2 again. And what's 2 times 2? It's 4. So yes, it really does cancel. So down here I could say, well, what that is, if you got negative 9 times root 2x minus 1 times root 2x minus 1, that will be negative 9 times 2x minus 1, like that. Okay. And then that will be over this denominator, root 2x minus 1. And I'll add to that 9x over root 2x minus 1. Okay, so now I've got a common denominator. how about this? How do you add when you have a common denominator? You add the tops over the lowest common denominator. So what I'm going to get if I do that, this here is really negative 18x, right? Like if you distribute plus 9, that's really what we've got. And we're going to add 9x to that. All right, and then that's over what? That common denominator. That's how you add fractions. We'll get our final answer like this. The negative 18x and the 9x, those are like terms. So I'll get a 9. Those make negative 9x. So I'll get 9 minus 9x over root 2x minus 1. Okay, there's my answer. That's algebra. That's not calculus. But calculus does involve some algebra, like it or not. Okay, so I give you warning that yes, there's some algebra that we have to know. So let's say this. Let's say that, okay, so we're okay with the chain rule. Okay. And then we can do the algebra. Then I think that we're probably okay for this problem right here. All right. So suppose the question goes like this. Determine the points on the curve, this curve, which I honestly have no idea what that looks like, but it looks like something. All right, it's a curve where there is a horizontal tangent. Oh, I misspelled. I do that occasionally. Where there is a horizontal tangent. Where are the points on this curve where there's a horizontal tangent? What does that mean? Horizontal means flat. It means a slope of 0. The derivative tells you the slope of the curve. So the question we're going to answer is, where is the derivative 0, or at what points is the derivative 0? Okay, why did it say horizontal tangent? Well, remember that, the derivative does tell you the slope of a curve, and, there's what we're supposing on this problem that there's a point somewhere on the curve where the tangent line is flat or horizontal. So maybe the curve looks something like that. We're trying to discover where that point is. Why might you want to do that? Well, because that would tell you perhaps where a high point or a low point on the curve is. But let's get to it. We're solving this problem. F prime is equal to 0. Okay, so how do you find f prime of x? All right, that would be the derivative of this. And you would have to use two rules at once. You would have to use the quotient rule because it's a quotient. But then when you take the derivative of that bottom part, that would be the chain rule. Why is that? Why is the derivative of root 2x minus 1 the chain rule? Oh, well, that's just this problem that I already did for you. See, that 2x minus 1 to the 1/2 power, that's root 2x minus 1. So when I work this and I do f prime g minus g prime f, I already have the derivative of that bottom part with the quotient rule. It's ready to go. It's right here, okay? So here it goes. Quotient rule plus chain rule, all right? So we got f over g. We do f prime. What's the derivative of the top? What's the derivative of negative 9x? It's negative 9. Times g. Okay, so that's 2x minus 1. Minus g prime. What's the derivative of root 2x minus 1? Well, again, I did that separately, okay? It's this. The derivative of root 2x minus 1 is 1 over root 2x minus 1. So we'll do 1 over root 2x minus 1, okay? So f prime g minus g prime f. All right. Over what? G squared. What are you going to get if you square root 2x minus 1? That's like multiplying root 2x minus 1 times itself. What happens when you multiply a root times itself? I mean, given that that number in there is positive, and roots are going to cancel. So we're going to get down here, we're going to get 2x minus 1. Okay? Okay. So I've got this now. Now, how about this? I'll do one more step, and then I think that we've got most of it done from there. Okay? So one more step. So this is, I can't do anything with that. All right, 9 root 2x minus 1. But this is like 9x over 1, that's a fraction. I mean, if you really need it to be, negative 9x over 1 times negative 1 over root 2x minus 1. Well, a negative times a negative, that would be positive first of all. And I get a 9x on top, all right, and a root 2x minus 1 on the bottom. All right, and then I got this 2x minus 1 down there. I don't know why I put a parentheses on it. I didn't need to there. All right, it's not wrong to do that, but there's no need to do it either, so I'll write it like this. Okay, now, what do we do from here? Now we have to add all that stuff together, and there'd be a lot of reducing, okay? But we already did that. You see that top part right there? I went ahead and I did that all by itself. Just because, I mean, can you imagine, like, say somebody had trouble with this part, and I tried to, like, do that in the midst of this problem. I'm just afraid that would complicate it more than it needs to be. So I have already worked that part at the beginning of the video. So that top part, just the top part, which you see right here, if you reduce that, you will end up with this, okay? All right, so we already did that. I'm just going to write it down. We got 9 minus 9x over root 2x minus 1. And that is over 2x minus 1. Okay. Now we're almost there. Not quite. We got a little bit more to do. How do you take care of this? Like, how do you divide fractions? I mean, I see this as I have one fraction divided by what appears to be a whole number, but that's more algebra. I mean, that's like saying what's 1/2 divided by 3. How do you do that? You might know it's 1 over 6, but some people, like, this is the kind of stuff they need to review. So, well, okay, I need to see it like it's 1/2 divided by 3 over 1, and the process for dividing one fraction by another, where 3 really is a fraction, it's 3 over 1, is 1/2 times 1/3. I divide by multiplying by the reciprocal. So yes, it is 1 over 6, okay? And I tell you that just because that's how I'm going to do this one. I'll put this with a 1 under it, and I'll say, okay, I need to take this fraction times the reciprocal of that. Okay, so what's that going to look like? We're almost there. We get 9 minus 9x over root 2x minus 1 times the reciprocal of this, 1 over 2x minus 1. Okay, one last thing. Before I'm done, and I'm going to go ahead and write f prime x over here, okay? And what do you get if you multiply these together? Well, you multiply straight across, so I'm going to have 9 minus 9x times 1. All right, that's not so bad. 9 minus 9x, okay. But what's the bottom part? Aren't we multiplying like things? Like I got 2x minus 1 to the 1/2 power times 2x minus 1 to the 1st power. How do you multiply like things? You add the powers. So I'm going to get 2x minus 1, and the power will be whatever 1/2 plus 1 is, and that's 3 over 2. That's not so bad. Okay, so yeah, there was lots of algebra in that problem, and I could review more of it. And that's something that if you need to review algebra, there's nothing wrong with it, but you'll have to let me know. I take the initiative to review some of it on my own, but I don't know what everybody needs, okay? Now, all right, so I got the derivative. What were we even trying to do? Let's look back at the beginning. I was trying to find out where the curve has a horizontal tangent. That means where is the curve having a slope of 0, or where is f prime equal to 0, because f prime tells you the slope of the tangent line to the curve, or it tells you the slope of the curve, however you want to look at it. So I need to solve this problem here, okay? All right, so how can we solve that? How can we solve 9 minus 9x over 2x minus 1, 3 over 2 power equals 0? Well, let's think about it like this. You could multiply by the 2x minus 1, 3 over 2 power, and get a 0 over there, and then solve 9 minus 9x equal to 0. I think it'd be worth telling you a little bit more than that. So let's just take as a rule, like, what's it take for a fraction to be 0? A fraction is 0 if the top number is 0 and the bottom number is not. That's the whole truth behind this. Okay, that's what it takes for a fraction to be equal to 0. The top is 0 and the bottom's not. Like 0 divided by 7 is 0. 0 divided by 24.76 is 0. You get the idea. So I need to see just, is it possible that 9 minus 9x is equal to 0, but then that bottom number isn't? Well, let's see. 9 minus 9x, that's the top. What makes that equal to 0? It's pretty easy to solve this. You'll get 1, okay? Does 1 happen to give you a 0 down there? No? Okay, so 1's okay. 1's your answer, all right? Okay. Now, I've got an answer, 1, but, you know, there's levels of detail to math problems. Let me look at the wording at the beginning, okay? Determine the points. What's a point? Is 1 a point? 1 is not a point. 1 is a number. This is a point. It has an x-coordinate, which is in fact 1, but a point also has a y-coordinate. All right, how are you going to get the y-coordinate? Do you use f prime or do you use f? Well, f of x is the curve. The graph are all the x's and y's that come out of that formula. F prime is the slope of the curve. You don't use f prime to find the points. I mean, the points are just the graph. You plug an x in, you get a y out. That's what the curve is. That's what this function is. So I need to say, like, okay, 1 for x, and what's the y coordinate? So I'll put 1 in for x, and I'll get the y. All right, so let's see. Put 1 in for x here. I get negative 9 times 1 over root, what's 2 times 1 minus 1? So 2 times 1 is 2, minus 1 is 1. So that's going to be negative 9. All right. That's the y-coordinate that goes with that x-coordinate. That's the point on the curve. All right. So my final answer is going to be this. Okay. It's not going to be that. And it's definitely not going to be this. Okay. Not going to be any of this. It's that. All right. Okay, so yeah, if you had the graph, like it's easy to find online graphing calculators and so on. You could graph that. You could find that point on it. I'm not saying it'll look exactly like this, but it may bottom out or it may rise up or something like that. But it'll be flat there. It'll be flat at that point. It'll be horizontal.